This is the last content that you do. This is the last question in the test or the exam. So the endpoint of exponential functions in general maths is using them in a realistic context. Right now, we've just done y is equal to something. The y didn't mean anything. Right now, we're going to chuck sort of what could be a realistic scenario there. Why are exponential functions useful? Because most stuff in real life doesn't grow linearly. Most stuff doesn't grow the same amount each time. So for example, bacterial cell division. Bacteria splits, it doubles each generation. So in the first generation, there's one. What was the term for it? I'm a bioteacher. Binary fission is how bacteria split and reproduce. They clone themselves. So it goes from 1 to 2. What would generation 3 be? How many cells would there be there? 4. Next. Next. So that's not linear. It's going to go up. It's doubling each time. It's not going to go in a straight line. Radioactive decay of materials is measured in half-lives, which is a term to say it's the time taken for the number of radioactive particles that are coming out of the thing to halve each time. So if there was 20,000 radioactive particles, maybe it might take a day to go down to 10,000. And then it might take another day to go down to 5,000. And it might take another day to go down to 2,500, etc. That's not linear either. That's decaying like this. And one thing you need to consider always is that while the exponential functions might be slightly different for growth or decay, you're always talking about the independent and dependent variable. We talked about the dependent-independent variable right in the first lesson of this. So the independent variable is the one that causes change in the other. The dependent variable is the one that just changes because of the independent. So in our case, for our model, y represents the dependent variable, and that power x is the independent variable. But now that we're going into actual context for the question, you're not going to call them independent variable. It might be area. It might be days. It might be number of freaking chimpanzees. It might be the length of Sephiroth's sword. You never know, all right? So, example. Get this example down. We'll talk about it. This is a realistic scenario. A scientist monitoring a grasshopper plague notes that the area affected by the plague is modeled by this function. A is equal to 1,000 times by 1.15 to the power of n. What does capital A stand for? It's the affected area in hectares. N is the number of weeks that have passed. I always find it important to visualize. Close your eyes and think about what is happening here. If you had a bunch of grasshoppers and they're infecting an area, what's going to happen to that area over time? Any thoughts? Is it going to get bigger or is it going to get smaller?
Smaller.
Smaller? Why? We're not killing the grasshopper. The grasshopper's going to be like that with each other, and then there's going to be more and more. It's going to the area affected is going to increase over time. And these numbers in the model mean something in the context of the area and how many grasshoppers there were. So once you've got that example, what are the questions being asked? What was the original affected area of the plague? What was the percentage the area affected was changing each week? What would the affected area be after 5 weeks? Find out how long it would take for the area to reach 8,000 hectares. So in that rectangle that I gave you, that's the 4 question types that you might be asked for this. How do I approach thinking about that? Is the model exponential? You tell me. Is x, is the independent variable there, is it a power? Does it look like the models that we've been doing? A times by b to the power of something? Yep. So it's exponential, yes. Is it in the form that we've been hammering? Well, I've got a y here equals, I've got an a here times by b to the power of an x here. So yes, it is in that model as well. And now you need to think a little bit. There's no maths here. The calculator is not going to answer this question in your mind. What's the independent variable in this context? Which variable here, the area or the number of weeks that have passed, which one is going to cause change in the other? Because the question's not going to tell you. The number of weeks. Because the amount of area that's been devastated by the grasshoppers is going to grow based on how long the grasshoppers have existed. It's not going to be the other way around, okay? So the independent variable in the context is n number of weeks, and that only leaves the other one, the dependent variable, A, area affected. You're not going to be asked to say those things in the question, but it's useful to keep that in mind when you're answering the question. So A, what is the original affected area of the grasshopper plague? Which number in the model tells you that? How many? Yeah, which number in the model tells you? Any thoughts? Interpret the value of A. Just read the question. Understand that A is the starting value of the dependent variable. So in our question there, in our model, what is A? 1,000. So what is the starting area that was affected by grasshoppers in the first place? 1,000 hectares. Yes, sir. So 1,000 hectares. B. By what percentage is the affected area changing each week? Where do I get that information? Well, if I look at the multiplier here, 1.15. What would 1.15 be as a percentage? No, you have to times it by 100. How many percent would that be? No, you convert. It's currently a decimal right now. We want to get it to a percentage. 115 is more like it, because right now the decimal is here. You times it by 100. So you could say something like this, answering this question, multiplier is 1.15, therefore 115%. So increasing by 15% each week. The area devastated by grasshoppers is getting bigger by 15% each week. How do I tell that? Because your multiplier was 1.15. 1.15 as a percentage is 115%. What would the affected area be after 15 weeks? How could I find that using my model? I have my model here. A is equal to 1,000 times by 1.15 to the power of the number of weeks. Is the question telling me the number of weeks? So all I need to do is change that n to the number of weeks, which is not 15, 5. 5? So grab the calculator. Split. Power of, so you've got 1,000 times by 1.15 to the power of 5. So that's telling you that the area is going to be 2011.36 hectares to 2 decimal points after 5 years. And then the last question type, as stated in the rectangle, I asked you to copy down. Find how long it would take for the affected area to reach 8,000 hectares. So my model is the area is 1,000 times by 1.15 to the power of the number of weeks. Question D. What is it telling me? Is it telling me the area or is it telling me how long? It tells me the area. So in my model, I know 8,000 equals 1,000 times by 1.15 to the power of n. I'm trying to find n here. Last lesson, 13D, I believe it was, you solved exponential equations. This is an exponential equation. Remember, you use the calculator to do a little shortcut to solve that. What did I press to get the graphing function on the calculator?
Y equals.
Y equals. What's the left-hand side of my equation? 8,000. What's the right-hand side? 1,000 times 1.15. So let's practice that. 8,000. 1,000 times by 1.15 to the power of... Can someone remind me the button I used to get the x? Xt theta n. So right now, what is this set up to do? Your calculator is going to draw a horizontal line at 8,000. It's going to draw an exponential function that curves up. So I told you press zoom, zoom standard. Am I going to see the graph here at all? No, because it's zoomed in to 10 by 10. What do I do to zoom out? Zoom. Zoom out, and you keep pressing enter. Do you personally need to be able to see the crossover properly? No, it just has to be on the screen somewhere. So is the crossover on the screen yet?
No.
Is it on there yet? Is it on there yet? Have you seen the blue line crossing yet? No?
Right.
Still not there. Why is it taking forever? Because it's freaking 8,000. Is it there now? Can I see a blue horizontal line and a red line somewhere?
Yep.
Now you remind me, what do I press to get the calculator to find the intersection?
Trace or second floor.
Second trace.
Yeah.
5 intersect. 8,000 is what I entered. That's what I entered second. I don't want you to guess. I want you to find it. So that's telling me intersect at 14.88, 8,000. So answer in a sentence. Therefore, it would take 14.88 weeks to reach 8,000 hectares. Okay? So now you've solved an exponential equation in a context that's more meaningful than just y and x. And you've seen the 4 different question types you'll be asked. That's it.